Hello everybody, my name is Lara Brunschwig and I'm here today to introduce the work towards domain-specific modeling environments based on augmented reality. I will be presenting the theoretical part while Rubén Campos-López will be showing the demonstration of our tool. I will begin by giving you some background of what is modeling, what is a model, and what is domain-specific language. So modeling is central to all engineering disciplines to specify, understand, analyze, and build a system under study. Models are the center part of modeling, and they can be built either using general purpose modeling language like UML, but also domain-specific language, which are tailored for a specific application area. These DSLs are mostly used for end users with no technical background. I would define a DSL with a concept being model that you define using an abstract syntax, and you attach to this abstract syntax a representation called a concrete syntax, so it's either textual or graphical, and in this case, we would say it's a graphical syntax. Traditionally, modeling takes place using a pen and paper or whiteboards, but it is also supported by tools via desktop like the Eclipse modeling framework, and more recently, the improvement of the capabilities of mobile devices like the computer power, the touch screen size, and components with like cameras and so on, has promoted the emergence of environments where the mobility can be used, which permits to model directly at the location of the system under study. For instance, going directly at the factory to model instead of going there, taking on a paper, and then going back on your computer at home. But now we came with one step further from current mobile modeling environments by proposing DSLs enhanced with augmented reality. And we're not the only one, but it's quite a crazy idea. These are three examples of AR modeling application. The first one is the IKEA app where you can put and place a piece of furniture in the middle of your room, so you can imagine how it will look like and what kind of decoration you can add into your home. Then you have the computer inventory. So here we scan the barcode of the Mac Mini and it displays some relevant information like the MAC address and the IP address. And finally, you have the leisure application where tourists can display point of interest on the side by focusing the camera on them, and they can follow the track to get directions towards nearby touristic spot on the real world. This new IDs paper has the following contribution. The first is the presentation of the concept of AR-based DSL. Then we showcase some meaningful application scenarios for AR-based DSL. We propose a model-based process to define AR-based modeling environments, and we show a working prototype called Alter. And this is what Rubén will be presenting. So now we have this beautiful table which shows what are the motivation and usage scenario we came with. So first I will define what stands P and D. So D is for descriptive. It means describing an existing system. And then we have P for prescriptive, which is describing a system to be constructed. So the first scenario of this table aims at augmenting the real world with physical objects with interesting information for the user. So for instance, the inventory we saw with the Mac Mini just before. And then you have one scenario which is meant for displaying information, and there's one for modifying this information. So these two ones can be applied, for instance, in the smart factories where you have some sensors and you can point at them and see, okay, this sensor is connected to another one or has this specific value. Then the fourth scenario supports designing some system. So basically, it would be the IKEA application and the leisure application we mentioned just before. And finally, we have a fifth scenario, which is for animated and dynamic behavior inside the augmented reality application. So for instance, you have the gaming ones like Pokemon Go that was quite famous for some time. Okay, so let's dive into the main core of the paper. So augmented reality using a AR-based DSL. So on one side, you have the physical object, which is at some location or identified with some marker. And on the other side, you have the concept being modeled. So the model object, which is defined with an abstract syntax. And in the middle, we need a concrete syntax. And that's where we came with an augmented reality one. So we provide virtual representation for a physical object, which represents a model object. here is the Metamodel for AR-based concrete syntaxes that we have implemented. So a Metamodel is another word for DSL, basically. So in this Metamodel, we said that we have an AR node, which will have a 3D or 2D representation. This AR node will be anchored, so it will be placed at some location, either by an actual location or using a marker like a barcode or QR code. And this AR node can have AR connection between them, and this AR connection can be represented either on the floor. So if you remember the screenshot of the leisure example where we had arrows on the floor, then you have the tips. So what we call tips is like in video games. So for instance, in some video games where an enemy or an objective is not in your point of view, you have some arrows on the side saying, okay, in this direction, there is something interesting. So this is what we call tips. And finally, you have the line. So it's just basically floating line between the objects. These AR elements are annotating the domain metamodel. So the domain metamodel is the system you're modeling. So for instance, a touristic model or IKEA models, this kind of example. We are using eCar eMorph language, which is from the Eclipse modeling framework. The tools that we have implemented is called Alter. It stands for Domain Modeling using Augmented Reality. And the idea is that you have on one side a DSL designer that will create the abstract and the concrete syntaxes and the 3D and 2D representation. It will upload everything on a server. And on the other side, you would have the DSL users who will be downloading all these elements on mobile devices. And these mobile devices have to be iOS ones, so iPhones and iPads, and they will be able to use and model as they like, depending on what the DSL designer has created. To give you a concrete idea of what is Alter and how does it work, now Rubén is going to show you a demonstration of that tool.
To create a new model, click on the corresponding button and a table with the different palettes is displayed. We choose one, and as soon as it appears, we press the Start button to activate the camera. Now we add a new object, selecting one of the options below and naming it. By pressing the Delete button and choosing your object from the table, we are shown a set of cells corresponding to the attributes of your object. By clicking on them, we are shown the keyboard with which we can type of your data. We can also cancel, change, hide the attributes, and even delete the object. We have added another object of different class to show how to connect two objects. Using the previous object, we can see at the bottom a list of reference. By clicking on the corresponding cell, we see a list of objects of the same class, in this case 1. By clicking on it, it changes green, and clicking outside the table, we close and the reference line is created. The reference line is attached to both objects. And if we move one of them, the line moves as well. All these changes can be saved locally by clicking on the Save button and choosing a name for the file that will contain your model. Once it's saved, back to the menu, we click the Load Model button on the right and select your model file. For the objects to be displayed, we need to point the camera to the exact saved location. The Hit button shows us where we made the save. Once pointed, the objects are displayed. We can move the objects to another position, as shown in the reference, but we can also pinch the object to change the size. And by swiping on some objects, we can change the 3D object version, in this case, changing the color.
So this is the end of our presentation. I hope you enjoy it. You can find the reference of a paper here, and you can also find the website of Alter, where you can have other videos and explanations about the tool. If you have any questions, feel free to ask them. Thank you.